think that we are, at some part, we are over-promising. So it could happen that we do not meet all the expectations, and specifically the expectations about AGI. They are going to be problematic on one side. On the other side, it does not mean necessarily that we will have an AI winter, because the rest of the club is probably doing things that are done right. So, developing businesses with machine learning and AI, having a healthy economy based on it. And if this works fine, we will not have an AI winter, despite not matching the promises of AGI, artificial general intelligence. In the past, it was a different situation. There was very little business developed, and all the promises that were not met were required to be met in order to build businesses. Today, it's not that problem. So it may happen that we don't have AI winter. We may have a few rainy days, but I hope not a winter. I don't see the same situation as in the past. Well, we are definitely much closer than they were. We did not quite meet the expectations. We have sort of make some of these things that were people hoping to develop. We made them work, but we are still lacking general applicability, general solutions that would work sort of very reliably for any type of problem and so on. So, like, say, speech recognition was one of the things that actually AI broke on, and was one of the causes of AI winter. Right? People promised we'll do speech recognition, and then didn't work. Now we have a speech recognition today, but it's much better. It does a lot of things, but it makes a lot of mistakes as well. The problem is not really solved. There's a lot of work to be done. So what people hoped back then probably was to solve the problem. So we are doing much better. We didn't completely have done it yet. We are over-promising on AGI, artificial general intelligence. There have been these very optimistic statements that within the century, probably in the first half of this century, we will have computers will be matching the intelligence of humans. And the neuroscientist part of me says that's completely not possible. These estimates have been made on calculating the number of synapses in the brain and amount of computation they require to calculate the per second the computation of a brain, and then looking the development of our technology and see when will the technology meet these demands, and that's the year when AI will meet human intelligence. But there are two problems here. One is that we don't know how the brain works, and we don't know what's important and what's not. Actually, we cut out from everything that there is in biological neurons a very small portion, and that's what we counted, and the rest we ignore. We don't know what's going on with that, but probably it's very important. That's one problem, which itself would postpone the technology meeting brain computational capacities day. But then there's a worse problem. Even if you had this machinery that is as powerful as the brain, it's empty. It has no knowledge, no skills, nothing. How are you gonna make it intelligent? One thing is having a computer empty the first day you buy it, and the other thing is have it inside an intelligent behavior of it. This could take a long time, and we have to know how to do it. We don't have a good way of doing it. The way how we do it today is training deep learning networks with large amounts of data. We don't even have that amount of data, and probably will never have that amount of data that would have required to train a deep learning to the level of human intelligence. We'll never have that. It's like, our biological system has been trained over evolution, over millions of years. And we're trying to condense it in 20, 30 years. It may be possible, but it's not going to be easy. It's not the strategy we are using today as a mainstream. It's not going to work. It's impossible that way. Well, machine learning has been used in neuroscience quite a bit to analyze the data, to understand better how the brain works. Not necessarily as a model of how the brain works, but as a tool for understanding how the brain works. And so you record lots of data about the brain activity, and then you can apply machine learning and ask a question like, whether can I train a machine learning model to do prediction about this and that about the brain? And if you can, then you have evidence that there is there's some information represented in this brain signal or not. Then you can go in more details and see how this information evolves over time and so on. And that has been used quite a bit. So machine learning is a very useful tool for studying the brain mechanisms. The other way around, how much the brain can help machine learning, that's very interesting. So the mainstream brain theory is kind of quite similar to the mainstream machine learning principles. But we know that the mainstream brain theory is not the right theory. We just don't have a better one. So the two have sort of evolved together over time. And as soon as one improves, the other one goes copies. Like if there's new algorithms in machine learning, brain scientists go look at them, let's see if something similar happens in the brain. And vice versa. If brain scientists come up with something in machine learning, people would take it immediately. Like, for example, lots of image processing today, the architecture that you use for deep learning networks have been copied from the anatomy of the brain, convolutional neural networks. Brain research has influenced quite a bit of that. Right? So they help each other and will develop in each other, and you have to have probably breakthrough, at least on one side. Which side it will be, I don't know. My feeling is that brain science would have to do it. I'm not afraid of super smart AI. And the reason for that is that AI cannot get super smart without our watch. I have looked at the scenarios that people describe, possible scenarios, how superintelligence could evolve. And they all include some sort of idea of intelligence explosion, like exponential growth in intelligence, where you build first a little smart machine and then you forget to switch it off overnight, and then the machine goes on the internet and collects all the data, learns from there, becomes even smarter, and then even smarter, and you forget for a week or two somehow, and you came up with a smart algorithm but didn't watch what it was doing, and then at the end, boom, soon enough the machine controls the world. And I don't know, launches missiles, controls air traffic, who knows what, buys and sells stocks on the market and becomes itself rich and powerful. I don't know. That's not possible. People who develop these scenarios have not understood or known the fundamental theorems of machine learning. Have they understood them, they wouldn't have developed these scenarios. It's not possible. You cannot get intelligence out of nothing. Or there is, for example, this theorem called no free lunch theorem, has this popular name, which basically says you cannot have one algorithm, machine learning algorithm, that's efficient learner for anything. If you have an algorithm that's efficient learner for one thing, it will necessarily be worse for many other things. So you will never have one algorithm that you just let out and it becomes intelligent. It's not possible. Such an algorithm would require learning time, longer than the age of universe or something like this to reach human level of intelligence, something like that. So what you need to, and due to this theorem, what you need to have is basically lots of efficient specialized algorithms. And to develop lots of specialized algorithms, you need lots of time for each of them. And if you want to advance the intelligence even further, you have to get a new one and a new one, which takes more and more time. And that took millions of years for us, and it's not, we cannot just trick it away through some, two guys in a garage, teenagers, really intelligent, come up with idea, code it, boom. This is impossible. That's like, the same level of impossibility as getting energy out of nothing, right? Yes, definitely. It's very likely that every business processes will use AI one or the other way in the future, probably in the near future. It's like, everybody's using computer today. Is there any business that doesn't use computer? Everybody needs it for a little something, to communicate with people, to do books, to everything. So AI is just going to be replacing lots of these tedious jobs that humans do, doing some new jobs that humans cannot do. Everywhere, definitely it will be. I cannot imagine that it's not applicable everywhere. We just have to find good ways of distributing it, creating it, training it.